There's an easier and simpler way to solve inverse trig function problems that nobody on the internet is talking about. I came up with this technique just a few minutes ago, and I think that is going to solve a lot of headaches. It has to do with the word arc. So whenever they throw the word arcsine, arcosine, it's new to us, and it's a hassle to solve these problems. And this should be a lot easier. So I came up with this technique by merging some of my previous knowledge from different units that I studied, and it works for every problem that I encountered, and no one talks about this on YouTube. So here it goes. We're going to solve 3 problems. They're in purple here. Arcsine, that one in purple, this one, and this last one. Now, let me tell you why the problems that I've found of the methods that I've seen on YouTube, and feel free to speed up the video if I talk too slow, click 2x and speed it up. But what I've seen on YouTube is that you gotta translate what this means, put an equals to x, so means, and then you gotta go and analyze where it is in the unit circle, and then pick the correct one. So that's a lot of steps right there. So that's one method. Then Khan Academy, which I really appreciate. Thank you, Khan, if you're watching this, that you guys made it for free. They look at a function here, and they have to choose, given the domain, where's the answer. Okay, that's another method. But my method is simpler and easier to remember long term. So check it out. The only thing for my method that you need to remember, and by the way, my name is Rafael Testai. This is me. The only thing you need to remember for my method is that arcsine is the inverse of sine. That's the only thing that you need to memorize, okay? If you know that, we can take it from there. But in order for you to come to this step, this is like step 2, I need to teach you step 1. And this is something that your math teacher should have taught you a long time ago. And that's what an inverse function means. Now, once you remember this definition I'm going to show you, I'm going to make it all logical. You're not going to forget it. Okay, so an inverse function. How do you remember this? Because I hate to memorize. Inverse, it means to undo what the function did. So let's go with really simple numbers. All right, so let's say that a function is, so f of a, all right, this is the same thing as saying f of x, but I just replace the x with an a. No biggie there. So f of a is 4 plus a divided by 2. That's our initial function. So what's the inverse function of this? All right, so I'm going to show you this little method that I have that I've never forgotten, and it's very straightforward. You draw these boxes, and this is the original function. This is the inverse function. It's all going to make sense to you guys. Look, you put in a number, that's a, into the function. So that's why the arrow here. You put it into the function, and then you end up with b, a number b, and you put it into the inverse function, and you end up with a again. So the key thing is that you end up with what you started with. These are always going to be the same. That's key to remember. So whatever you put into your inverse function, you end up with the same number that you started with. So if you have an initial function of 4 plus a, I'm going to do it here, plus a divided by 2. What is your inverse function? How do you figure that out? And you see that this is a little different from the videos you may have seen on YouTube. And the part that I hate about, I really do, hate is a strong word, but people always use x and y. And they put the x here and the y. But it's so much easier to remember what an inverse function means if you use the numbers, the letters a and b. So you never get those confused. So let's do this one. So f of a equals, and let's say that a equals to 2 to make it super simple. 4 plus a divided by 2. We're going to use the number 2, and that's going to give us what b, I'm thinking out loud. Okay, so when I put the number, let's use a different color, 2, and 2, 2, okay. f of 2 equals 4 plus 2 divided by 2. That's going to be equal to 6 divided by 2, which equals to 3. Okay? So f of 2 equals 3. And that is 3. There. That's what we came up with. And then we need to plug that 3 into this inverse function that we haven't come up with. We plug it into the inverse function, and that needs to give us a, okay? Alright, so let me erase what I just did there. But how do we figure out what the inverse function is, what the equation for that is? It's actually very simple, since we're going to be using the variables a and b. If this was our initial function, and it gives us b, then we need to isolate a. Okay, so 4 plus a divided by 2 equals b. We need to isolate this guy, as simple as that. So times 2, and that's going to be b2, 4 plus a, minus 4, so a equals b2 minus 4. That's our inverse function. And that's going to be f of b equals b2 minus 4. And how do we test that our inverse function works? This all has to make sense to you guys before we can move on to the next step. And this inverse function that I'm doing now for you, this is something that you need to learn for everything to fit in moving forward in your math career. Math is, you have to build on steps, one on top of the other. You can't skip. If you have holes in your knowledge for math, it's hard to build a foundation. So how we test that that was correct? Well, if f of a, when a equals 2, so f of 2 equals 4 plus 2 divided by 2, we conclude f of 2 equals 3, as we had up here on the left. When I plug in 3 in here, I need to equal 2, because remember a had to equal 2. Alright, so f of 3 equals 3 times 2 minus 4. So this is 6 minus 4. F of 3 equals 2. And that's correct. That's what we wanted. So we filled it all out. We filled out the inverse function right here, and we made sure that our output equaled our input. So to summarize this, just so you can have a big picture of what we just did, I put in a number that we're going to call a into this function. It's an f of a. Usually they call it f of x, but we're going to call it f of a for simplicity, to make sense. Whatever comes out of this function, like this is the answer, equals, we're going to call that b. Then we throw b into this function, f of b. This is the inverse. We're going to undo whatever we just did over here. And then we need to end up with a, the same number. So that's how my brain works when I look at this inverse function. Once you know this, let's move on to trig and see if we can make sense of all this. All right, let me erase the whiteboard. If you like what you see so far, please give it a thumbs up and leave a comment. But let's see, here's the whiteboard. So what is this problem initially asking us? The initial problem was find arcsine this. So arcsine 1/2. And the guy was like, okay, give me the answer. What is arcsine 1/2? 1 square root 2, excuse me. Find the answer for that. All you gotta remember was what I told you guys initially. Arcsine is the inverse of sine. That's all you gotta remember. If you understood what an inverse function is, if you remember that, you can do this. So let's do the 2 boxes like I taught you guys. This boxes, if you just remember how to do those boxes, you're set. All right. So we know that that's gonna come here because that's the inverse, like we said. So arcsine here's the magic. It's all going to come together for you guys. We know that this half, 1 and square root 2, is the answer. It's like what we're plugging in. Because arcsine is the inverse function, and this is like the b value. Remember? B equals 1/2. But let me get rid of the b so it's less clutter. Alright. I'm going to get the calculator out. Did he specialize well, what mode we're in? Okay, let me see. Calculator, mode. Let's do degrees. Alright, let's just keep it in degrees. So let's go to the calculator. We're going to go and do second sine. So in the calculator, it actually looks like this. And we're going to type 1 divided by square root of 2 equals 45 degrees. So I know that 45 is the answer. And remember what we wrote initially? So if we know this is 45 degrees, it has to be the 45 degrees up here. See the dots connecting now? Okay. So now I need to put 45 into this function, which was an initial function. And looking at the definition, sine is the original function. So if sine is the original function and we plug in 45, then we should equal with this number here. So let's try it. I'm going to get my calculator. Sine 45 equals sine 45 equals 0.707. And if I test what 1 over square root 2 is on the calculator right now, sorry, decimal place in the wrong place. So these are the same. So essentially, it did equal. So the green check mark, I mean, we got the correct answer because we ended up with the 1/2. We plug it in, then we plug that in here. All right, so that's the answer. 45. Let me double check that I got the problem correct. Yes, arcsine equals 45 degrees. All right. Now let's do this one from Khan Academy. He wants to know what arcsine is. Arcsine 0.98. First thing you need to do is look at radians right here. So we're going to go to the calculator, mode, radian. All right. So same process, guys. We do the boxes because we have an inverse function. We know arcsine 0.98 goes here, which means that we must have gotten 0.98 from the initial function, the original function. So let's do in the calculator second arcsine 0.98, and that's going to equal 1.37. So we know if the output is 1.37, the input for the inverse function had to be 1.37. Okay, so we know that we're putting in 1.37 into the original function, and by definition we know that sine is the original function and arcsine was the inverse. 1.37. Now we're just confirming. So sine 1.37 in the calculator, it should equal this number, which we later plugged on here. But let's test it out because we want to make sure that we get this right on the test, and double checking is very important. Equals 0.9799, which is the same thing as 0.98. Yes, we got it correct. So equals 1.37. Let me double check that Ken got the right answer. Yep, the answer is there. But let's look at what Ken did. And yeah, he graphed this function and he had to choose a domain. I think that's more complicated, guys. My method that I came up with, well, I don't know if I should call myself the author, but I haven't seen anyone else on the internet do this. It's much simpler. All right, let's do one more, and this one is a little bit harder, but I really enjoy doing this one because I'm going to add to what I showed you guys. If you're still watching this, give it a thumbs up. All right, so same method as always. You can pause the video and do it, and then come back. All right, we're going to do the boxes. Arcosine, because it's the inverse function, negative square root of 3 over 2. Man, what did he... Let's do radians for this one. All right. Let's do mode, radians, correct. So Arcosine, negative square root 3 divided by 2. Oh, this one's going to get really interesting. I love this one. 2.617. But they wanted it in radians. Okay. All right, so I'm going to show you how to get this to radians in a second. And I also came up with this myself. I didn't read it anywhere, but here we go. 2.617. So we need to put 2.617 in here. And by definition, the original function was a cosine function. Cosine of 2.617. Well, in the calculator, let me clarify. This 2.617 keeps going. It's 9, 9, 3, 8, 7, 8. Keeps going. So I need to convert this into radians. Like, how many radians is this? And this was my logic. If there's any mathematicians or geeks following this, I think that you're going to enjoy this. I noticed a particular trend. I wanted to convert this into pi, into radians. And I noticed that 2 pi equals 360. I'm just going to throw out like all the different pi's here. A pi divided by 4. You see pi divided by 6. Pi divided by 2, etc. But you always see even like 5 pi over 6 and just all these different numbers in the unit circle that represent the angles. So I noticed that if I want to solve for the decimal, what this decimal means, I figured that it had to be a number. It could be like a number like 1, 2, like this will be equivalent to pi over 2, of course, which is 90 degrees. But it had to be like pi divided by 2, or some number here, some number equals 2.617. But I didn't know what this number was. So what I did was I turned this into the letter z. So I said, okay, z times pi, and z is a number, an unknown number, equals 2.617, etc. And what I proceeded to do was divide by pi, so I could isolate z. So I'm gonna, in my calculator I have this big number right now, and I'm gonna divide it by pi. So divided by pi equals 0.833. And I'm gonna go math fraction equals 5, 6. So if I know z is 5, 6, I'm missing the pi, as you can see right in front of it, so I'm just gonna put the pi right there. So it's 5 pi 6. 5 pi 6. So 5 pi 6. 5 pi 6. And then I'm gonna put 5 pi 6 in here. Well, really the arrows, I don't want to duplicate the arrow. The arrow was already here. So cosine 5 pi 6. Let's put that in the calculator. Cosine 5 pi divided by 6 equals, this is equaling negative 0.866. And 0.866, like, you always gotta look back at your pattern, at your boxes, what this number is, where should I put it. So let me use a different color. Negative 0.866 should be equivalent to negative square root of 3 over 2. So I'm gonna put negative square root of 3 over 2 in a calculator. Negative square root of 3 over 2 equals, yes, it equals the same, negative 0.866. So it all checks out, guys. The answer was this, 5 pi over 6, but it all checks out. The number that we initially had, the input, put into the original function, I'm going to use a different color, the yellow, put into the original function, You end up with the b value that I showed you guys before, b as in boy. You put the b into the second function, it gives you the output, and the output, we converted the output into radians, and the radians are the same initially. See, if you guys like this, give it a thumbs up, like, comment, share, subscribe. Rafael Testai.